Cool
Oh,
little
I'm
setting.
in. Yeah, it's a little bit different setting. I'm in New Orleans for
Ah,
SPATCE. It's like a big
nice.
oil and gas technical conference. Uh,
All
I'm in
right,
charge of bringing a bunch of students.
cool. So we got New Orleans, Philadelphia, Austin, and I'm in New York City right now. So good coverage. Cool. Well, we were going to today uh, go over some updates on the research that I think we're close to being able to just order some monoliths. And one of the things that Ling was going to explore is, can we get some free samples before we make an order? To be honest, I think the price is low enough and within budget that if that's slowing things down, I don't mind just going ahead and ordering several of them that have different cell space and allow us to sort of play around with things a bit. And she also set up, her and Christina, which I don't know if you two people have met her before, but she's been kind of a wonder worker for our GitHub. And Ling set up a basic sort of project dashboard where we can list down the things that we're going to work, and we'll organize those roughly along the lines of the subgroups that your team has, because as we discussed before, that maps really well with the actual project. But I just read on the Discord she's got some big long meetings, so she might not be on here. But we can get as much information from her as soon as she's done, and catch up next week. Oh, this might be her. Yes, she's here. All right. Hey, Ling.
Hi.
How are
Can
you?
you guys hear me okay?
Yeah,
Different
we can.
setup.
Yeah, I wasn't sure if you were coming. I knew you had some meetings and stuff. So.
No, no, I'm now officially unemployed. Oh.
Oh no. All right. Let's make you famous through this project. Not gonna. I'm sorry about that, Ling. Hopefully,
Oh no, it's
hopefully
okay.
it's up.
Yeah, it's not anyone's fault. Well, it's some people's fault, but
Yeah,
my team worked really hard.
I've been there before. I was there this summer, so we'll talk about that. Cool. Well, I was just saying that we were gonna talk through one of the things I shared with you, Charles, was about 2 seconds ago on the Discord. Was just a few slides that are just good visual, basic general sort of visualizations of the different parts of the unit that we're proposing, that I thought would be helpful for your Thursday meeting. And sorry I didn't get it for you last week. I was on a plane. And I thought we could talk about the monoliths a little bit, Ling, and maybe if the where we are with the GitHub project tracker. But before we do that, Will, Tom, and Chaz, how was last Thursday's meeting?
It was really good. We had a really good turnout. Again, we expected large diminish, but we still had 35, I believe the number was, which is, well, didn't lose that many people, which is good. I also think that we gained some, so it probably was displaced by that a little bit.
Yeah,
But we had an opportunity to dive a bit more into the sub teams. So, Will gave a great synopsis on our arc with the chemicals and how they work, because everything else, or the sorbents rather, because everything else, centers around the sorbent. So that was a really, really important talk. And we kind of assigned them this last week to just kind of, on their own, do some research, find out which team they're interested in. And so we're hoping to launch into role assignments with this next upcoming meeting.
excellent,
Yeah.
cool. And Will, so it was a thrill seeing David for the first time in person. We were together in Philadelphia. That was fun, David. I'm so glad you got to make it. Hope you had a good time.
Yeah, I tell you what's really interesting to see is how many people Chris knows. He's,
I know a few. I
he's
know a few
like,
people. Yeah,
yeah,
I know a few people. This is my labor of love, this project, but most of it is sort of wonky policy stuff, which is what I was talking about on the stage. And David was probably, "What the hell is he talking about?" Because that doesn't come up. But one of the things that me and David did is we did a little stealth sort of visit to the UPenn lab where the Epiphyte is. I shared some pictures of that last week, but I did manage to not get arrested bringing some sorbent that I got from there across state lines. So we can play around with that, Will. I'll bring it over to you this week. It's the zeolite molecular sieve, which
okay.
we didn't like, but I know it does get used with monoliths. So we have a big bucket of that. And then the other one, which is the Luatit, which is apparently a great sorbent, but it's not great at the heat that we need to put it in. But I'm going to give it to you. You can play around with it. But the real grab we got was the new sensors, which cost about $200 altogether. So I was able to grab those, and those are at my house in Austin. So that's a thing that I'll also hand off to you guys as well. All right, cool. Ling, did you want to talk at all about? I know you did some further sleuthing around the monolith stuff, and I'm not sure if you talked to Christina yet, or what the state of the GitHub project is.
Yeah. Yeah. So there is progress on both. Not as much progress on the monolith as I would like. So we can probably hash it out here. Okay, let's talk about the monoliths first, and then afterwards we'll talk about GitHub, because I think there's action items on both, and some of them will be just mine. So on the monoliths, I think we're gonna go with something like a container that's cylindrical, right? And if we do, then we can get something like 8 inches, and then like I don't know how long it will be, like 12 inches, 6 inches, 8 inches. I don't really know. I think we can pick one, get multiple materials so that Will can test it, and then get Chris to place the order. I only really talked to one vendor on Alibaba, and they were it's like clearly a Chinese vendor the way they respond. But very helpful. They say that they can basically make anything we want. They
How long does it take to get? How long does it take to get?
Yeah, I don't really know. I think we need to find out, but I should have called this other vendor. But like, I'm only officially unemployed today, so I didn't have time before. Maybe I'll also call. Actually, let me look up. Let me look up the other part that one of the other parts that also makes monoliths. So the vendor that I talked to on Alibaba, they can make. So I think David, you missed it, but we were talking about alumina versus cordierite and what the difference is. And I'm not an expert on this. Will is, but the idea is that alumina, it is better for PEI. I don't know what the term is, but it's basically like chemical grafting. And then cordierite is better for just like wash coating with Luitid, or I don't know, one of the other ones. And there is one that is not Alibaba. And if they're located in the US, then I'll give them a call right after. If they're located in China, then yeah, okay, they're in China. Okay, so it might not make a big difference. I think I'll just go with that one in Alibaba. One of the pieces will be a sample, and then like a second piece we may have to pay for, or it could be a sample of a different material. I don't know. But either way, we'll have to pay for shipping. So Chris, I will send you maybe like, or like put you in contact, or I don't know. I'll figure out something with the person.
Let me know. Just send me the thing, and I'll order it immediately, or as soon as we're ready to go.
Yeah. So the thing we do need to decide is how long we want a monolith to be. If we're going with 8-inch cylindrical, what do we want?
I think the pipe part. Yeah, the pipe part there, the one that we put in the early bomb, we assumed like 24 inches. So we could do, like 3 6-inch one. If those are the standard ones that are off the shelf, I seem to be finding that. But ones,
I don't think. I think they can make anything we want. If we're doing, 24 is big. 24.
That'd be cool though, because then we could get one big monolith or a few of them in there.
Also,
would increase the. Go ahead.
Is it concerned the size of the? Because we're still doing the chimney as the outer structure of this, correct? What's the max dimensions of that concerning the monolith?
If we're using clay chimney, so the stainless steel ones are 8 inch inner diameter, but I think it's possible to use the clay. Interfacing will be a challenge, I think, but you can make it much bigger. I don't remember what the maximum.
This is a
You
big
can,
decision where I'm somewhat inclined to go ahead and order the chimney parts for this first one, just because they're off the shelf and they meet our size specs. There's also different ones. You can get ones that are wider and taller and stuff like that. And then test it out with that, and then move on from clay from that. It's harder to get these parts in clay, particularly if we don't have the ability to print or mold it. That's my leaning, but curious. I love the clay idea, and I like the idea of doing that next. But if we could just get these things together and get one working, and then see if we can recreate it with clay, that's the direction we're going to.
I think we need to order the monoliths first, whether it is gonna fit the container or not, because so Will can begin testing. The clay decision is more complicated than you think, because one, the body of the clay thing is really heavy. It could be like 100 pounds. Well, maybe it's like 40 if it's short, like 18 or 24 inches. But it's really heavy, and I don't know how to do a bypass on that one yet. I have to think more about it. Um, the interface, it's harder to custom make that just because of the heat requirements. But if we can get the monoliths to Will, usually the chemical part of an ensemble of a system will have longer turnaround times or whatever to develop than the mechanical part. So I don't think we're gonna like make a wrong decision. Well, like we can just buy more monoliths if we need a different shape, but I think we need to get something going. So
Yeah.
Can I offer some input just real fast about some of the things I was thinking about? What is the total length of the chimney right now that we're looking at for the bomb that you just showed us, Chris?
We have options there, but the one that we were looking at as our sort of we thought was good is the 8-inch interior diameter and 24 inches long. So if you look at that pipe, that's what that is.
Okay. So I guess if we have, I think so. Yeah, I think what Ling said with getting the 8-inch diameter monolith now would be good. But then in terms of the length of it or the height, I think I would be against getting a really long one right off the bat, just because I can see difficulties getting the PEI onto like the inner parts of it. So like the grading or the honeycomb, I can see that being a stopping point, or maybe it just being difficult to get it all the way through and get it like evenly distributed on all ends. So I think probably going with shorter heights and more, I guess, like smaller chunks of monoliths to fill up the whole 24. You said it was 24 inches, right, of height?
Yeah,
Yeah,
we could do
it
smaller.
can vary. Yeah, you can get 12 or 18, whatever.
Oh, okay.
We'll need some leeway. Like we're not gonna fill up the whole length, right?
Gotcha. Okay. So yeah, I think I'd be on the side of getting the 8-inch diameter. Also, we should be sure that the 8-inch diameter monolith can actually fit inside of the 8-inch inner diameter. Did we already check that if it's 8-inch
We
inner
don't
diameter?
know.
Okay.
So
We could get
what
6 or 7 though, right, Ling? I think they have them in all kinds of
that's
sizes.
not the problem. The problem is tolerance. So I know what Will is saying. If you get something that's 8 inches, you get pipe that's 8 inches, you get a monolith that's 8 inches. It's possible for the monolith to be like 8.05 inches diameter.
Yeah.
And the inner diameter of the other thing is like 7.95. So we need to get something that's slightly smaller than 8 inches on the monolith side, and then we're gonna pad it with something if
Right.
it doesn't fit perfectly. That's what we're gonna do, I think.
Okay.
In terms of the monolith,
yeah,
so
Go
sorry.
ahead.
How difficult would it be to, like, if there was a scenario where it was too big? I'm sorry, I'm trying to picture the monolith in my head. So there's like a solid circle around the edges of it, right? So you can't just like cut it shorter, can you?
I think you can, but it'll be hard. It's ceramic.
Right. Okay.
Oh,
Oh, okay. Yeah.
very evenly, maybe. Yeah, I think it's better to just stuff something in between. I don't know
Okay.
what. Maybe there's some kind of heat foam or silicone gum. Even gum would do it.
I
Yeah.
had an idea. How about this, guys? What if we do one that's 8 inch, or whatever, 7.5 or something, diameter monoliths that are heights of 2 inches, 4 inches, and maybe like 8 inches, and just see which one. Because I think those are small enough that we can test them out and see how well we can wash coat them. And I have a suspicion that the 8 inch one, which is like 8 of height and then 8 of diameter, that'd be a little bit too hard. So I'd be on the bigger scale just so we can test out those three and see which one's the easiest. I suspect the smaller is easier, so a smaller height would be easier to wash coat the PEI onto. Um,
Yeah.
but then we run into an issue of like having way too many little monoliths inside of it. That may or may not be a bad thing. I don't know, depending on like how
Yeah.
sturdy they are, how much they degrade. Because if one dies, we can pop one out and then put another one in, right?
Also,
We can do a
the
bunch of
grading
those, right,
process.
Will? Sorry. They have those ones that are like this small and circular. So we could do a bunch of those and put them together. The only thing is we want to do is have some line going through so that all the cells line up so that they're not, the cells aren't not lining up because that'll create a lot less airflow. But I think you could just figure that by putting some, little dowel or something to the cells to make sure they all line up. But we could do a bunch of little ones if we wanted to.
Okay.
I don't know.
Do we think that we will go as short as 2 inches? It is not, so we're probably gonna go with something like 100 CPSI. So pretty not dense. Hopefully like low back pressure. But I've thought about the challenges of having multiple monoliths in serial, and it doesn't really reduce the loss and pressure to have smaller ones in serial. So I do want to go with something smaller in diameter. I think it would be easier for you, Will, to do the dipping and stuff. But do you think the challenge would be of coating the inside will be so much that we might have to go down to a 2 inch long cylindrical, or do you think we can start at 4 and then try like 8, 12?
I think going too long would just be an issue because you'd have to submerge it completely in the solvent, and that'd be a lot. So I'm just trying to imagine that'd be like some kind of like bucket, like 4-ish a gallon size that I'd be dipping these into, which isn't necessarily an issue, but just doing that, I feel like it would be a lot of waste too, and I don't know if I have enough like of the PEI to make that concentrated of a solution when it gets big like that. The scale, because I've done it at a small scale right now, like 20 mLs. If I bump that up to 1 gallon size, I feel like I don't know something might go wrong with the actual procedure. Like it might crash out of solution, like the PEI might not want to dissolve, or I need a lot more of methanol or something. So I'd like to try it on the small, even though we may not use 2 inches. I like to just give that a shot and see how well that is. And if it looks totally feasible to scale up to like gallon size or liter sizes, then we can get the big monoliths and then go ahead and use that.
They got these kind of guys too, Will, which are probably more like 4 inches.
Okay.
Trying to upload another picture, but there's a whole bunch of varieties. If you just Google round, alumina monoliths, you'll see that there's a whole bunch of them. And the Chinese manufacturers are like, what can I get for you? Usually that's based on volume, but there's a bunch of different kinds. So, which I think you had mentioned, Ling, before about the alumina cordierite difference, and that alumina was better for PEI. But Will, it's your understanding. Oh, I thought you said that first, and then you asked Will. Will, it would still be the wash coating. It would be the same process though that we'd use, right? For alumina and with the PEI that we've read about already.
Yeah, it'd be the same thing I'm testing right now, and I also have some data I want to show that's pretty promising for the alumina powder that I got. We can still try cordierite though. If you're able to get like a monolith that's also cordierite, I can just test that out as well.
The same vendor can do both materials.
Okay.
So,
do you know if they sell cordierite powder by chance?
I don't know about the vendor. Yeah, I could ask them. They seem to be like a monolith place, but yeah, I can ask them. I'm sure Alibaba we can probably find someone who does a corduroy powder, or wonder if you can get it off Amazon.
That's what I was gonna check. Yeah, I was gonna put that on my list because the only reason is so I can test it out for our gas absorption to see if I can even get PI onto corduroy, and then
Okay.
what its performance is, and then we could potentially use because the idea with corduroy is it's just cheaper, right? Or it has better thermal stability or thermal. It can get heated up quicker or something. Or what was the?
I think it's less brittle. I think alumina is more brittle. So like when heating, it might not stand alumina might not withstand the heating as well. But I'm not sure if it's a huge difference. I'm not sure if it's
Is it
big.
cheaper? Is it a lot cheaper than alumina?
I'm not sure if it's a lot cheaper. Probably
Okay.
similar.
Okay.
Monolith
I'd
seemed to be
be-
the same price.
Okay.
Like what I looked at least. But yeah, go ahead.
Okay. It'd be cool to say that we can do this on corduroy or alumina, like just give those options out and like have it out to the world, like whatever. And
I just dropped a link from eBay that I just found of corduroy powder. So
Oh,
that does seem to be a thing. So it's in the comments section there if you want to file that.
Yeah, Amazon
All right.
doesn't really.
Cool. Will, did you want to share any data, or should we do that now, Ling, since we're talking about that stuff, or did you want to go back to that?
Let's make a decision. So I'll ask them to make a 2-inch. Do you mind if we go smaller, or just like go with fewer options, just so I can not hassle them so much? Because technically, I want to ask them for the same thing for the 2 materials. So I'm already asking them for 2 things minimum. If you want to do a 2-inch and like something bigger, then it'll be 4 items, and then I don't know
2 inches
if
tall, right? 2 inches tall and like a 7-inch
2 inches
diameter,
tall.
probably. So
Eight or 7.7 3/4 probably. So
Okay.
maybe like one is 2 inches in length, and then another one could be 4 or 6.
Yeah, let's get a couple of 6s and some 2s of both, so that Will can easily experiment with them. Right? Does that sound good, Will? Or
yeah, I think 6 is fine. Yeah, let's do 6 and 2. I think that's a
Okay.
good range.
Okay. Yeah, I will ask. It
Okay.
will be one of each. Is that okay? Or should we just, if we want to go crazy and just order more stuff, let's just order
Well,
more
let's find
stuff
out what
now.
it costs. But I would say if we had let's give ourselves a couple of let's see if we can get 5 of each of those or something like that. You know what I mean? Just for playing around with.
Also, I mean, if the plan is to, if we, especially with the smaller one, you're talking about making a structure in the middle to make sure they're lined up, to make sure they're not like covered up. Is that you're done like carving out a center point and putting like a hole to that? Is that what your intention was, Chris? Or what did you mean by that?
What if you can just have like a really thin dowel or something that's metal or something that you could just put through one of the cells and have it line up with the other cells, just so that they're completely lined up. I don't think it has to be anything complicated, but I don't know what you guys think.
I think you could use like 4 of those dowel rods. So if one, they could still be misaligned. I think actually.
Yeah.
But maybe if you have like 4, like 2 on one side, 2 on the other in the circle.
What if
Going
I
what
think
if
you only need 2.
if the
Okay.
placement of the monoliths were just like there was a slight gap between them? Couldn't you do the same effect without like breaking flow with the dowels? Or
It shouldn't matter.
okay.
Yeah. So they're supposed to be pretty big cells. I wanna say I've never seen them in person. But if there's a gap between them, it shouldn't be a problem.
But I figured that that'd be the best because I'm afraid the dowels might like I don't know produce certain like connections. I don't know. I might.
Yeah,
I don't know enough about
think you
airflow.
only probably need two dowels, if at all. If they're large cells and the monoliths are produced identically, then you can just visually line them up, and there's no need to connect them.
Yeah, they'll be
Um,
tiny, right? 100. What is it?
CPSI.
CPSL. Yeah.
Yeah. Is that too small? Should we
That's
go
what he
50?
recommended. Kirsch did. He thought that was like a good balance. Could even be as much as 200, but he said 100 would work in terms of packing sorbent in.
Okay.
That's what they do. They being Clarity Tech.
Mm.
I was just saying that might be a reason to maybe get multiple for that reason. Like see if the dowels cause a serious problem with that, or if we should just gap them, or if like stuff like that, like leave them normal and just gap them that way. See if there's a difference between that kind of systems.
Yep.
If that's
So,
worth it.
yeah, so I think this will be a concern, but I don't think it's like a blocking concern. And
Okay.
I feel like the testing could be done, like we could get a good feel of what how they physically behave before we decide on these things. I think we'll make another order for shapes that we believe
Yeah.
will,
Yeah. Okay.
will work.
Well, Ling, just let me know, and if you want to loop me in, if it's even easier, whoever you talk to. But I got a credit card that's burning a hole in my pocket here, so I can order those whenever we're ready to go. Will, do you have enough PEI kicking around the lab right now, or should I just go ahead and order our supply of that?
Yeah, let me think about how much I should scale this up by. I haven't done any of the calculations, but I have I have a jar that's full of it, so probably like 100 grams or so. But yeah, I'll give you some numbers, and then I'll see if we need to buy some, and then I'll also look on like the prices for like Fisher and like Thermo Scientific to see how much they sell it for, and I can. I don't think it'd be a bad idea to have like an extra jar of it, because if we're gonna, I think even with like the 2 and the 6 inch height monoliths that we're getting right now, I think even that could easily use up. I personally think we should try and put as much PEI onto it as we can, and I think that's probably gonna be one of the first things I'm gonna test out. Is like, what is the limit of PEI that we can get on there before it starts like just chipping off or caking off or doesn't want to stick onto it, and then maybe potentially like multiple wash coatings onto it if that's also a thing.
What happens if you put too much, say, and you accidentally put so much that it's blocking the holes? Can you remove it?
Oh man. So if we got to that point, I think I wouldn't even work if we started blocking the cells. But what I foresee could happen is that if you have one layer of the PEI onto the monolith first, that's well and good. It can be grafted onto it. But then the second layer, it may not graft directly onto there. It might just be what we call impregnated. So it's just kind of on the surface. It's just intercalated onto it, but it's not covalently bonded to anything. So it looks like there's stuff on the surface, like on multiple layers. But then when you start running it, it may perform fine. It might absorb CO2. But then when you heat it, that last layer that's on there isn't as strongly put onto the surface as the bottom layer. So it might start coming off with heat, or maybe even just pulling vacuum or whatever. And that could be the concern, because we might have super high performance right away, but it's only like a one-time thing. You burnt it off after using it one time, and that wouldn't be ideal.
So it'd probably be best to try that out before assembling the whole thing. Just coat the thing and then put it in an oven or something just to make sure it holds up.
Yep, definitely. Yeah, because I do foresee that doing multiple wash coats would be the best way to get the most onto the surface, because I don't think doing just one run of it with the wash coating will cover everything perfectly. You'll still have some gaps where there's more surface area where you could put some more on. So maybe we could do 2 or 3 wash coats, but I don't want to get into the issue where we start caking it onto it and they have multiple layers that aren't actually grafted on there. That'd be the issue. But we have to find out where's the sweet spot with that.
Yeah, the point is to maximize surface area too. So we want to cover as much surface area as possible without compromising quality.
That's why with the cells too, sorry, Chris, the density of the cells, I like the idea with more cells, because even though there's potential for them to maybe get clogged if there's too much PEI in there, that's more surface area, and we can just have more opportunity to add the PEI into it. So I really like the density, or whatever the term is, to like have more of the cells within the monolith. That
was the thing that Kirsch mentioned too. Is your bigger issue would be the clogging of the cells. He did actually mention that we put on.
Oh, okay.
The one thing we could do again is you have a little tiny like needle kind of diameter thing. That's a lot of cells, but as we look through it, you might see a little, bit of a chunk of of the PEI sort of obstructing the. We can just like poke it through and kind of almost do like angioplasty on it if we need to. So. All right, cool.
Yeah.
All right, so we'll order that as soon as possible. Ling, if seems relevant to the test that Will did, should he report out on that, or do we want to cover anything else in terms of orders?
I'll do the order. Why don't you guys take care of PEI if that is still in the plans?
Yeah.
Yeah.
One other thing I'll mention too, maybe I should do this too, if it's helpful for you guys, just take 90 seconds real quick to just run over the basic parts here, because we have the UT team. Some of them are watching right now, but then it'll be recorded. So Tom and Charles and Will, if you even want to show the recording of that, it might just be helpful. But it also, we can point to the parts that we think we're relatively firm on and the things that we still have to sort of figure out. Is that okay if we just take 90 seconds for me to zip through that with these slides? Okay, cool. So
That'd be awesome. Thank you.
The main thing we're focusing on here is, this sort of core Epiphyte, and it has the damper on top, and then it's got that sort of T piece that comes from the chimney supplier, where we want to put the damper and the fan on the side, and then below that there's heater, which we'll talk about. We haven't made any decisions on that. And then there's a part called a slip, which is basically almost like a top hat that's made out of the same material, that's perfect for adding those other parts on top of that could also fit the heater in the bottom. And the monolith, whatever the dimensions, would fit right into the pipe, which we'd put in before we put the damper on. And then there's this bypass tube that we've been talking about that Ling has been exploring. And I think we thought Ling would be more like a heat tolerant sort of bendy tube that we could then screw a hole with like a gasket or some sort of sealing thing that would be cost effective. This looks about right to you, Ling? Oh, can you guys
Sorry,
hear
I
me?
stepped away. I went to get water. Yeah, I'm listening. Yeah. So, to be clear, the bypass is David's idea, but yeah.
That's okay.
All right. The bypass doesn't have to be as heat tolerant as the body.
Yeah. Okay.
Sorry, David.
Go ahead, David.
It's okay. Is there going to be like any kind of active fan to push the hot air up, or is it just going to be convection? Okay, here we go.
Yeah, that's the thing we have to think through. So just real quickly on the adsorption phase, that's quite simple. The dampers open up, the fan pulls on, it pulls air through and it goes up, and then it saturates the monolith. So that's relatively simple. The one that we still have some question marks around is during desorption, where we close the dampers, we're heating it up. We're hoping we get some benefit from going vertical, that the heat will go naturally go up, but we want to push it a bit too. And there, I don't know what we're thinking. If it's a small fan like this that would either go on the top or the bottom, that has to be able to.
Can you go up a slide or maybe two?
Sure. This one here?
Oh, yeah. Okay.
Or this
so the blue is supposed to be a fan. I don't think we need that fan. I think we can just have a fan behind the heater.
So here, though, right? Like
yeah,
there?
Yeah. Okay. The bottom one that looks like a fan, that's the fan that we need, and then we can turn the heater on and off. Then the other one that's on the side that looks like a drinking bottle, we don't need that.
Yeah, that's just for adsorption, and then we need a little circulation fan, right? And there's a bunch of those that I've found that can get really hot and high pressure and stuff like that. So they're usually around $80 that I think would fit nicely right below the heater. And that only Ling has to be like very light, right? Just it's not like going crazy. It's just enough to sort of push the air.
We don't need the fan that pokes out on the side. So we now need a bottom fan to multitask for both the adsorption and desorption.
Oh, really?
Yeah. Am I?
If you want.
Am I right? Well, David.
So you mean get rid of that T-shaped thing and put the big on the bottom?
I think we need a T-shaped thing for vacuum, but we don't need we don't need two fans. We can just have the fan next to the damper. I forget inside or out. And then
Yeah, I kind of, it seems though that during the adsorption phase, you want the fan to blow really hard and fast.
Yeah.
But then during desorption, you want it to go slower so it can heat the air a little better.
we need to control the speed of the fan. We need the fan to be controllable.
But the
Yeah.
problem is too is it's on the which side of the damper is it on, right? Like
The bypass is supposed to come in on the bottom side of the bypass is supposed to come in above the damper but below the fan. That's the other part that we're missing. Oh, maybe I'll redraw this picture.
yeah. Part of me though thinks Sling. Oh, go ahead.
No, go
Somebody's
ahead.
about to, is just these bottom fans are quite cheap and they can operate in high heat and even with some pressure. It just to me, and what David just said is like the other fan is meant to like be like a really, really serious fan. And it's on the other side of the damper when the dampers are open. I don't think it kills us to have another little small fan to just like push the air up to give it sort of a boost. See what I'm saying? Like I don't know.
Yeah.
Like what do others think?
I think
Go ahead.
I do think that, like, in our experience, especially with like the goal of energy conservation kind of thing, splitting up different parts of the process into separate machines is sometimes better for energy, like in terms of energy consumption that it's going to be doing. Because again, trying to keep it like negative in terms of carbon, right? Yeah. Also, this is a side note, but wouldn't the circulation be running? I don't think this really matters, but like, wouldn't the circulation be running the other way if we're using the bottom fan to spin it? Like, wouldn't it be going counterclockwise?
Oh,
Yeah, that was just
Right.
my silly graph.
I was just trying to picture. I was just trying to picture which fan was blowing, and I was messing with my head a little bit. But okay.
Yeah,
I've got it.
imagine that going counterclockwise instead of clockwise.
Okay.
But yeah, good point.
But I think if you want like a serious fan to be taking air into the DAC system, I don't think that's a problem. I think a good thing to look at is like, are the heavy duty fans that can survive that heat and pressure, are those
Yep.
substantially more expensive than splitting them into two, or is it more like, I think the question is financials, right? At the end of the day.
They're not that expensive. I found this one here. It was only $89, which I'll show you a picture of right here.
Is that the heavy duty one or like the small one?
It's the little one. The heavy duty one is
Okay.
one that is probably the same one that we used for the last one. So if I share my whole screen, if you look here, where is it? Sorry. Oh, here it is. This kind of thing. I was thinking just for the air circulation fan, and these are designed to be very hot and, in fact, in chimneys. So I don't know. That's what I was sort of thinking based on what we discussed.
Does it
before.
come in a round version?
There are round ones. There definitely are round ones that in my research I have found. So we could find a round one that would just fit, right. If we go back to this here, that would just fit right on the bottom beneath the heater, right? It would blow out to push the air up.
We're right now, just to be clear, we're talking about removing that fan in the blue area, like the blue kind of shaded zone, and just making
I don't think
the
we
fan
should.
at the bottom. Okay.
Yeah, because I think we need both. The only reason why is because the way that we have the fan there is you open up the damper and it's on the outside of the damper. We need a fan that's on the inside when the dampers are closed that can be really hot, but it doesn't need to go super, super fast or be really strong, where we're supposed to have that for the adsorption phase. It is supposed to be pretty pull a lot of air through there. So I think we can do both and it doesn't break the bank. But
Okay.
Again, what am I talking about?
So it's not a money issue. I'm now stumped by this. It's more of a simplicity issue. If you add more parts to an assembly, it doesn't always make the problem. Oh, it doesn't usually always solve the problem. It often does not, because if we can find a simple solution that takes both problems into account, it'll be better. Chris, can you put the fan link into the spreadsheet so I can look
Yeah,
at
it is in there. Which fan? The big one or the little one?
the one that you just showed that you
Yeah,
said
that's so if you go to the bomb that we're working on, you'll see under the chimney parts. So right here, under the chimney components, it's the thing that says fan right here.
Oh, it's a difference. Okay.
So you can click on there. Okay.
Okay.
Also, with that bypass tube, because I'm assuming that's going to be open and like just pretty simple, like simply attached. It's going to be open during the phase 1. Is that going to cause problems for like the air flowing through the monolith? Like, is that going to kind of?
Yeah, that's a really good question.
Yeah, it
Thank you.
depends. Maybe, isn't there some kind of one-way valve? It's just a passive thing that only lets the air go in one direction. That could maybe go in there so that when you're going in the absorption phase, when you're blowing the air hard, that thing, you really only want, I don't have see the picture, but
I'm
the
not
air
sure
to-
if it's a huge concern because we'll have dampers open and dampers closed, right? And that opening will hopefully be bigger.
Yes. I'm just worried about like, especially if we split it into 2 fans, like if that's the idea still, like we stick to the blue area fan. If I'm sure the diagram isn't exactly how it's going to be built, but it's flowing directly into the bypass from where that's located.
Yeah, we
so-
can also point the bypass a certain way. Well,
Yeah.
the build of the bypass will already be a mechanical challenge, and I have not arrived there yet
Okay.
with the solution. But these are really good considerations.
Very. Yeah.
Honestly, it might be solvable just by like putting the bypass higher up so the fan's not blowing directly into it. That could be the entire solution for that. I don't know.
Oh, yeah. I think the bottom of the bypass needs to be below the heater.
Oh, does
yes,
it?
I agree.
Oh, because you want the right. Oh, okay. Yes.
It
Okay.
even needs to be
Get heated
below
up.
the fan that is blowing the heated air.
Okay. So the top of it will go on above the monolith, and then the bottom of it will go below the heater. So it's a much longer bypass, right? That's what you're saying, Ling?
Yeah.
Is it possible to have both fans running during phase 1? Because that
You
pushes away
could.
from the bypass.
You would need the second one, I don't think, right? For phase 1? Because it would be this.
Why would you want both fans running? What's the
I was just
purpose?
thinking it might push it away from entering the bypass. But if it's lower, actually, no. Never mind. Never mind. Forget anything. Sorry.
Putting 2 fans like stacked on top of each other, I'm not a big fan of that idea. I think one fan will block the other one.
Wait, no. Look at here, though. That whole reason why putting this thing on the side prevents that.
Okay.
So again, it would be like this under phase 1. Nothing is happening below this. You're just pulling air through it.
I
Like
see.
that. Nothing's going. I think I have my arrows wrong there, but
Yeah,
but
maybe the fan should be at the outlet, and then it pulls it upwards outside of the damper, and then we would just have a vent. Actually, we don't need a vent. We don't need a T if that happens. We just open the damper at the bottom. The fan at the bottom doesn't really need to span the whole cross section, right? It's just a heat circulation fan. Okay. Screenshot of this.
Could you switch the order of the? So let's pretend we don't have this side thing anymore. We put the big fan, either on the bottom or the top. Could you put the fan first and then the damper on the outside of it, so that during phase 1 you open up the damper and you pull that, but it would allow us to do double duty on that other fan by putting it at a very low speed and you'd be able to shut the damper, so the fan would essentially be inside the damper.
Sorry, can you say it again?
If you look at the way it is right now and the way we've always done it is you have chamber, damper, fan, right?
Mm.
But if you put chamber, fan, damper, then during the desorption, you open up the damper and it's fine. The air is able to get pulled through. But then when you shut the damper during desorption, you could put the one fan on a very low speed and it would still be closed. And now with the bypass valve, there'd be more circulation. And you could even have a thing where one of the things they research is like, you could time the fan where it only blasts like incrementally in bursts, just enough to sort of push the air up so that there wouldn't be as much pressure accumulation, I guess. Does that make sense?
My brain can't work as fast.
Wait, I'm sorry, Chris. So you're saying that the fan is at the top of the machine in this example, right? You're talking about that fan?
Yeah, that's the way we originally had it. If you disregard the bottom part there with the T valve,
yes.
You have a fan there that is just pulling air up, and then presumably the other damper's on the bottom, I guess. But what I was wondering is if you just reverse the order of the fan and the damper, where you put the fan below the damper, then we could use the fan to do the circulation function as well at a much lower speed.
Like kind of pull in that direction.
That fan still needs to be able to withstand heat, though.
Yeah, that's true.
I think that was your concern for having two separate fans. The fan, it doesn't matter where the fan is. It only matters where the fan is with respect to the bypass.
Okay.
Why don't I draw up another picture? Chris, you can make it look pretty later. But right now, like, I just want to get confirmation on the proposed positions of all the components. I don't know how to build them yet, and I can't build them while there's other stuff going on. Okay.
If you want, also we can have our mass transfer team start to look into that as well, like in terms of how that.
Sorry, one more time.
We can have our mass transfer team at the deck, like all those students, start looking into it as well, like how that placement might differ, airflow and different things like that. That'll help you.
I think the placement is not a challenge, although I think it would be good for your groups to discuss it. It's always a good intellectual discussion. The challenges will be finding a fan that is gonna work for our purposes, so like having the heat tolerance, adjustable speed. If we can get it to adjust, be tolerant of heat and be able to go at high speed, we don't need two fans.
Right.
We can get away with one. The other challenge is to make the bypass, and with a clay pipe, I haven't quite figured out how to do it. Just because a lot of times I would just custom make parts, and now because it's huge and it has to deal with a lot of heat, it's not as straightforward.
Okay.
Chris?
Well, let's assume stainless steel for this first one, just because we can order those parts.
Yeah, it's more expensive, but what can I do?
We have, it's about $1,000. We have, for this first one, if we could just build one, this shape works. This is how the air flows through it. This is the heat, the sorbent works. Then the next
For the
one.
bypass, you need a lot more parts. If you want to include the bypass, it's more expensive. It's like 17 or 1800.
Why? No, I don't want to use the metal bypass. Like as we've discussed, if we have some kind of a bendy sort of tube that we would drill holes in the sides of the pipe.
You gotta have air leaks.
What?
We gotta think about how to do that, because if you have air leaks,
yeah, no, I get it.
It's like if it's a metal pipe, then you have to interface it using something specific, not just like drill holes and jury rig it.
Oh no, I assume that. I think there's probably enough parts though off the shelf between chimneys and HVAC that are meant to create those sort of seals. So we should just explore that as a problem that we want to optimize.
My suspicion is that this company probably has a monopoly on their interfaces. That's usually how it works. And trying to interface with their chimney is not going to be straightforward.
Let's
Um,
that can
anyway.
also be a problem that the mass transfer team can explore, like the bypass
Yeah.
system in general.
Sounds good.
That seems like a little bit more of a one that has a lot of different directions. So
Mhm.
Yeah. So Chaz, I have those slides that I just showed, in addition to just a couple of other ones to sort of, look at how the whole thing would be put together that I think would be helpful for people. So I shared this with you on the Discord. So if you want to, now that we're having this discussion, you can point to people like, we don't quite know, here's the weak link in the chain with the bypass, the things we have to solve for, go ahead and share that for tomorrow's meeting for people to start to think about, I think.
Yeah, definitely. We'll probably, as we talk about those points, kind of find out who is interested in kind of wanting to solve that specific issue as well.
Okay, cool. All right, we got 9 minutes left. Will, maybe we'll get to the GitHub next time, Ling? And
I don't know if we should talk about it this time, if that's okay, because we need people to make accounts. And that's going to be it's going to take a while. It'll be quick. It's pretty straightforward.
Do you guys have GitHub accounts, just present people on the call here?
I think I have one from
Very
a class we had a while ago, but I haven't opened it in a while.
Yeah, then we just invite you to the team and you can be part of it. I just wanted to give Will a little bit of chance if he did some research and found out about it, anything that's pertinent.
Well,
But we
do you
can.
think that's higher priority?
Show the slides.
I would say the
yeah.
GitHub thing. Yeah, go for it.
Okay. I don't know if I can do it all in 9 minutes, I'll be honest. Maybe I should have gone earlier, but I can kind of give the Cliff Notes version, or maybe wait till next time. I'm not too sure. There's kind of a lot I wanted to talk about because I'll show data, but I kind of got to explain what it means. I can try, or we can, I don't know. What do you guys want to do?
Let's try.
Okay. All right. Let's see. Okay, I think I'm sharing one of my screens, right?
I'm not seeing anything.
Oh, okay, let me try this one.
Oh, here you go. There you go. There you go.
Okay. Coming
Great.
up.
Go ahead and... Okay, I guess I should probably just give a quick recap of what I actually did. So for those that weren't present last week, or just as a quick reminder, basically what I did is I took a procedure that was found in the literature, and I took PEI, dissolved it in methanol, and I put it onto 3 grams of alumina powder. So this is just alumina powder that I had in the lab. Ideally, this would be something that's similar to what the monolith that we're going to get should be. Clearly, this is a powder, and the monolith is like a solid structure. So there's just different properties there. This would have more surface area as a powder, but the idea is still the same. So the premise of what I was trying to do was just see, can I wash coat PEI onto this alumina powder? And the way I was going to show that would be to see how the gas adsorption changes after and before. So before and after the PEI has been washed onto the alumina. So that's what I did, I think at this point 2 weeks ago. So I dried out this powder. This is PEI here. I dissolved it in methanol, suspended the alumina powder inside of the methanol PEI mixture, and then I dried it out. And then my plan was to take N2 cryogenic isotherms and CO2 warm isotherms. So this is just like an example isotherm. This is not the actual data. I have that on the next one. But I did this kind of as a quick run. So I did the cryogenic 77 Kelvin cryogenic ones. But for the CO2, I want to be more careful with these. So I might actually redo these and use a water circulator. So instead what I did is just did it at room temperature. With these isotherms, you want to control the temperature, and adsorption is generally it's an exothermic process. So it'll give off heat to the environment. So that means if you're not controlling the temperature around it with, let's say, like a circulating water bath, then some of that heat will build up onto the sample, and that will change the adsorption properties of the actual material as the analysis is running. So you want to be able to control the temperature. I didn't do that as carefully just because I wanted to do a quick run to see if this worked or not. But now that I have confirmation that it did work, now I'm going to probably use the water circulator to do it at let's say 25C or something. So disregard this data. This is just an example one I showed to the DAC team last week here at UT. as to like what an isotherm looks like. But this is the actual data that I got for us. So there's kind of a lot going on here. So I guess the first thing I should just explain is like what is an isotherm and what these are. So here is the isotherms for the PEI onto alumina, and then alumina powder precursor just by itself. So this like reddish color is the alumina powder, and then this bluish color is the PEI onto alumina.
I think
This-
you're frozen for me.
Oh shoot! Okay, sorry.
I can hear you. Oh yeah, you're sliding.
The
Let me try
slide is like still the first one.
Oh, okay. Whoops. Oh, dang. All right, that didn't make too much sense then.
Yeah.
Let me see if I can pull this up.
Yeah, right.
Okay. Cool.
Is it frozen still, or is my pointer
Yeah.
moving around? Oh,
It's frozen. Well,
Oh,
your
dang.
pointer
We
is
see
frozen.
that slide though. We see the right slide. I think the line 25, 24 cryo and two
Yeah, you
of
can
those.
verbally describe.
okay. So the left-hand side, this is the full isotherm. So there's an adsorption and a desorption branch on these. So the gas that we're analyzing is, or the gas we're using to analyze it is nitrogen. And this is done at 77 Kelvin. So you literally take a dewar of liquid nitrogen and you submerge your sample into it and then just dose in the gases at low pressure all the way to saturation. So I kind of want to explain what the x-axis means for these plots. So on the x-axis, if you look down there, it says relative pressure, P over P naught. What that is just the pressure. So some pressure that that the instrument actually doses in, divided by what is known as the saturation vapor pressure of that gas. We're using nitrogen gas, and at cryogenic temperatures, which is 77 Kelvin, nitrogen will be a liquid. So the saturation vapor pressure, or the pressure above that liquid, at 1 atmosphere, at that temperature, which is 77 Kelvin, is 1 atmosphere, or 14.7 psi, or 760 torr. So what that means is that all the way to saturation, which is all the way to the right-hand side on the x-axis, 1, that just means that you dosed in 1 atmosphere or 760 torr of pressure, and you basically condensed liquid nitrogen gas onto the surface. Hopefully that makes a little bit of sense. You basically go through a whole range of low pressures of nitrogen all the way to saturation. And the only reason we can do this is because liquid nitrogen at 77 Kelvin is a liquid at 1 atmosphere. So kind of like confusing there, but this is what is like standard in the field. And what these isotherms show us is that if you look at the red one, the alumina powder, it has a higher uptake of nitrogen compared to the PEI. So that kind of seems maybe a little bit backwards, because you would think that, oh, maybe like once you put PEI onto the alumina surface, you would have a higher uptake potentially. But it actually makes sense that the PEI on alumina is lower because PEI has nitrogen containing groups, and our molecule of the gas that we're using to analyze the surface is nitrogen. So since PEI has nitrogen onto it, it will repel some of the nitrogen gas. So it will make adsorption, even at the cryogenic temperatures, more unfavorable. So I guess long story short, this first plot on the left shows us that our uptake for N2 gas went down after we added PEI. So that means there actually is PEI onto there. If there was no PEI or very little, you'd probably expect to see the exact same isotherm on the second one as what you did with the alumina one. But since we have a decrease, that's a good indication that yes, we do have PEI onto our surface. The right-hand side plot, all that is just the desorption branch taken off. So this goes, the way the instrument takes the data is it starts at low pressures all the way on the left side of the x-axis and keeps dosing in data points all the way to saturation, and then it goes backwards. And that's why you see kind of like a open loop, and then eventually it closes as you get back down to lower relative pressures for both the blue and the red curves. So on the right-hand side, all it is was take off the desorption and just looking at the adsorption. Desorption is important for other information, but in terms of just like how much CO2, or for in this case nitrogen gas, you can get onto the surface, the adsorption branch is a little bit easier to look at. So that on the right-hand side, all that plot is just the desorption branch taken off. Does anyone have any questions? It's kind of like a lot of information, but does it make sense what I just explained, why PEI uptake for nitrogen went down compared to alumina?
think
I know.
you would
I know you know it, which is all I need to know. But
Okay.
Dave and Ling might have smarter questions.
Yeah, go
I
ahead.
think watch this on YouTube. It's too fast for me. Sorry.
Dang it. Okay. I guess like I have a couple more slides, but I think I'll probably just cut it off at this one, and we can talk about the CO2 ones, which are it's a little bit more complicated for the CO2 ones because the data looks funny. But for the CO2 ones, we have a higher uptake at the pressures of they're relevant to DAC for the PEI onto alumina than alumina by itself, which is another indication that we had the PEI grafted onto the alumina. But just for the data that I've showed right now, the cryogenic N2 ones, the main takeaway is that alumina by itself has some uptake of N2 at cryogenic temperatures. And when we put PEI onto it, the uptake actually goes down because PEI has nitrogen-containing groups, which repels the nitrogen gas absorbing onto the surface. So the fact that we see a decrease in the uptake on the blue curve compared to the red curve is a big thumbs up because that means we have something on the surface, which is the PEI, there's repelling nitrogen gas. So basically it's giving evidence that it worked, which is really, really good because I wasn't super sure how the synthesis would work out, if dissolving it in the methanol was going to work because it's kind of tricky to do it because the PEI is very sticky. But this gives good evidence that it is working. And then when I show the CO2 stuff for next week, I'll try and spend a little bit more time explaining what the data is actually showing us. And that basically it tells us that at DAC conditions, direct air capture, low partial pressure CO2, that we are getting more uptake for PEI onto alumina, which is another big thumbs up. But I'll show that stuff next week.
Sweet.
So I'll stop there.
You have papers that you can post onto the Epiphyte channel, so I can read it. I don't really understand these isotherms very well, so it'd be good to read some papers for everyone else as well.
Cool.
Okay.
Either
Well, I got to bounce to a session, so I'm gonna have to turn off. But real quick, Will and Tom and Chaz, are you guys gonna be on campus on Sunday, or is that already premature? If so, I can run down and drop off some of the stuff that I nabbed from UPenn.
I'll be for a bit. I don't know for how long, but definitely for a little bit.
Okay, let me know. Shoot me a message. All right, guys. All right, thanks. So talk to me. So go ahead, David.
Bye. Thank you.
Okay, bye, guys. Catch you later.
See you later,
Bye-bye.
Chris.